Well, thank you all for coming back for part 2 of the gentle introduction to ROS. I'm Paul Bouchier for the camera, and this last time we went over how ROS works, kind of at the theoretical level. We talked about what we're going to do this time is go into some actual software. So there was a request to walk through some programs that actually do ROS master, ROS publish subscribe operations, and a request from Kareem and David for an ultrasonic demo. So I got myself a Robotics sensor and wrote a little driver for it this morning, and which is partly why I'm late, so sorry about that. Okay, so you remember from last time that ROS nodes, they call them, they're processors, publish, so a camera can publish a topic on a topic name like image to perhaps a CMVision node that might publish blobs on a named topic like blobs. A control node might subscribe to that and publish velocities. For example, on topic name CMDVal, these topic names are fairly standardized within ROS, and that might actually run a robot. So we're going to do something very close to that. So
what do you mean by publish?
So publish means like in a newspaper. It means you print some information, you send it out. You have no idea whether someone has received it or not, and you don't care. You don't want to care.
You're basically broadcasting, right?
You're broadcasting, yeah, to anyone that's subscribed, and everyone who's subscribed will receive the broadcast. Does that make sense? It's a different model than the call response.
But I guess I'm thinking more of hardware in. What do you mean? Physically, what's going on?
Okay, so this is a software concept applicable to messages. It's in the hardware analog would be a wire with a single driver and potentially multiple receivers sitting on the wire, listening to whatever messages are sent over the wire. Does that make sense?
Go ahead.
So it's just optional whether you have something out there that'll process this information.
Yeah. But let me ask this, is it essentially that you just broadcast it out on the Wi-Fi or Ethernet or whatever, and then when somebody wants that particular one, they pick up those messages as it gets broadcast out?
Conceptually, that's what it's like, but the actual implementation is more sophisticated. You've got this thing called a ROS master, which everybody who wants to publish or subscribe to registers with. Right. And says, I want to publish this topic, or I want to subscribe to it. And the ROS master says, okay, you want to subscribe to blobs, go to this IP address, this port number, and that's where you'll find blobs.
Okay.
So the processes are communicating with each other through the TCP/IP stack?
Exactly, yes. It's all TCP/IP.
I think that's the answer to
Yeah, okay.
Okay.
And the guy in the middle there, I'm sorry I forgot.
The ROS master.
The ROS master essentially is acting like a DNS server.
That's exactly what it's doing, yes. It's a name service for anybody who wants to publish or subscribe on a topic.
Does that help with diagnostics in a complicated system?
Yes.
I mean, because I assume there's a way to look at, okay,
very much
is
so.
there something publishing blobs?
And we'll do
Is
that.
there something
We'll echo topics to the screen so we can see what data is flowing across the topic.
Okay.
There's a plot utility where you can graph topics.
Okay.
Paul, I guess one quick question is, since it's working on Wi-Fi or TCP, are there other stacks or whatever that could work with Bluetooth or UART, or do you have to be on the Wi-Fi?
It relies on TCP/IP. So any transport that supports TCP/IP is really what could be used.
Okay.
So basically that amounts to wired Ethernet, which isn't very useful for robots.
Yeah.
Or Wi-Fi or cellular networks.
Okay.
I'm still trying to sort this out at the same level. These processes that are talking to each other, then it's not like they're talking through pipes. They're actually,
We're talking about processes on the same processor? Or
that's what you
separate
said.
machines?
The processors could be on the
same.
same processor or they could be somewhere else. It doesn't matter.
But even if they're on the same processor, they're talking to each other through the TCP
Yeah, it's
stack.
probably
Through the
gonna go
TCP
it's gonna go
stack.
to the loopback interface at that point.
And so the latencies and so forth involved will always be those involved with the
Yes.
comm stack.
That's exactly right. And just to re-emphasize that point, because it's a very good point, TCP has a characteristic where if Wi-Fi drops a packet, it'll retry after a while, right? But it can be 5 seconds, 10 seconds before it retries. So,
No.
yeah.
Are they timestamped so that you can know that?
Yes, most of the messages are time-stamped. So for that reason, the Turtlebot driver, and it's a good thing for other drivers, should stop the robot if it doesn't receive command bell messages every now and then, because there might be a hang up in the Wi-Fi. So, yes, that is a weakness, if you want to call it that. It is a characteristic of ROS as a transport. It uses TCP, and TCP can hang if it loses a packet.
So Paul, let me ask you if this would be a valid robot. So, I've got, say, something like a Pi 2, hardware Ethernet to an Ethernet card on an Arduino. Would that be a valid robot?
Pi.
A Pi 2 running ROS.
Yep.
Okay.
Yeah.
And an Arduino with a Wi-Fi shield or Ethernet shield, just hardwired hooked to each other. Would that be a
Yeah.
potentially
Yeah.
valid
Yeah.
ROS robot?
Yeah. And let me go further with David's question about losing packets and latencies. So leaving aside the fact that TCP does have variable latency, non-deterministic latency in transporting packets, because of this Wi-Fi issue, what you really want to do is you want to run the ROS master and the nodes that matter as far as navigating the robot and controlling its motors and detecting and running its sensors. You want to run them on the robot wired on a wired network, so that the chances of dropping a packet and having a TCP timeout are minimal.
Well, my question is actually, I think, simpler than that. Yeah. Ignore a Wi-Fi connection. We just have a robot and it's running ROS. There's no other computers involved. The nodes on that ROS robot are Linux processes.
Yes.
But they're talking to each other, even on that one robot, they're talking to each other through the TCP IPs.
That's correct.
When you define those, do you give them an IP address, or is that what the DNS server does?
There's a very nice function call which we'll see called init, and it does all of that magic for you. So you never have to see any of that stuff.
So it assigns an IP address and a port
No.
specific to each?
No, actually,
Each
okay.
process can talk to another process on Linux through the loopback interface.
Yeah,
And it's just by port.
yeah,
It's the same IP address, different port.
yeah.
So you've got a source port and a destination port, and the same IP address still talk to each other.
So when you define the process, the node, you define the port? Assign.
I'm assuming it's using dynamic ports and basing it off these topic names.
And that's what
Yeah.
all right.
Yeah.
Go on, Paul, I'm sorry.
Just a real quick one in there. I just remember doing some streaming stuff, and maybe you can tell me something about this. In that case, I was using something where I didn't, because the age of the packet mattered, I was using UDP,
Mhm.
and that didn't, that would just broadcast stuff.
Right.
You didn't care about,
Right.
saying,
Right.
oh, I didn't get the packet or whatever, because the
UDP,
packet was
UDP
aged.
doesn't act, it's a stateless connection. So
Okay.
you're just throwing them out there and you hope they
Yep.
get there. They don't all get there, so what?
Right, so would
Whereas
that not be
TCP, every
supported?
packet has to get an act packet. If you don't get the act packet, you retransmit it.
Right. I was just thinking if you wanted to cut your overhead down a little bit in cases where you were broadcasting, let's say, I don't know, let's say a blog position, and, if it's aged and a packet gets dropped, you don't so much care. It's more like, hey, I want to reduce my overhead.
So
Is
I'm not
that
sure if you can use TCP, UDP. There are a few references to it in the literature, but I've never actually seen anyone
Okay.
use it.
Okay.
And
Just turn off the
just
main
to
log.
just to extend upon the question about how do you know what IP address to go to, in the case where you've got multiple processes, you do set an environment variable that says the ROS master is here, and then everything that wants to subscribe or publish goes to the ROS master. You do actually identify its IP address, and then the ROS master will tell any processes, oh, you want to connect to this publisher? Well, go to this IP address and this port number. So yeah, localhost, if you're all on the same IP address, and actually it's done through an environmental variable. So the default setting for ROS master URI, which is the environment variable that tells where to find the ROS master, is localhost port 11311. If your ROS master was like on the robot, and I had my laptop here, then I'd set ROS master to the IP address, to http:// IP address of the robot, port 1311. Okay? Okay, so what I thought we should do this time to get ourselves, because we really want to go through the code, so we're going to like go deep and fast here. But stop me if you have questions. Is go through a little C++ syntax that you'll need to know. I'm assuming everyone here knows C. But not everyone knows C++, so there are some syntactic things that you'll run into when you're looking at ROS programs that I don't know, if you guys are anything like me, when I look at a language I don't know and I see funny symbols, I'm like, what the heck does that mean? And it kind of distracts me from understanding the flow of the program. So I want to cover that. I want to do some ROS PubSub demos. And then walk through code for a publisher's subscriber, show you how to create a new project. Most IDEs have the concept of a project where you're building one or more executable programs. So how do we do that in ROS? And then work on code that does robot control from a sonar range sensor. And then a couple of other more advanced topics. So C++ syntax, you'll run into this a lot. And let's see, should I do, yes I should do start from current slide. Does that come out? Yeah. Can you guys see that?
Yeah.
Okay. C++ has an operator, it's called the scoping operator. It says 2 colons side by side. And it means use this namespace for the name that follows. And so you can think of that in terms of English and German. The word fast, we know what that means in English. German has a different namespace. The word that is the same, that's spelt the same, sounds the same, actually means almost in German. In a similar way, ROS has a name called publisher. It's the name of a class that publishes on topics. I could define a namespace called Paul's Robot NS and define publisher, a class called publisher there, and it would be a different class. It could do something completely different. So it's a way of avoiding name collisions. And the reason you want to know it is because of this little syntax down here, you'll run into this continuously, ROS : and then some class name. You find that all through ROS. All of the ROS classes are prefixed with the ROS namespace. Okay. I'm going to skip that one. You'll run into templates, and I'm not going to go into any depth here, but they're a way of telling a class or a method what type of object it's supposed to handle. And the way you'll usually find it is in this. Is this arrow showing up? Yeah. Is in a statement like this: pub1, being a publisher, equals node handle. So we declare node handle dot advertise. And then we're saying message type 1 on topic 1. And so, and down here at the bottom is an actual typical expression that you find in ROS. And so don't worry about the angle brackets and what's inside it. Just know that it means the kind of message that is to be published. And so you'll have to plug in the appropriate kind of message when you write this kind of code.
It's like typecasting.
It's different than typecasting. It's telling the compiler what kind of message, what kind of object this class is supposed to handle. And classes may or may not handle that, but the compiler will throw an error if they don't.
Okay.
So it provides for type safety in C++. C++ is a strongly typed language. So, okay. Okay, that was all the C++ syntax, so that wasn't too painful, right? Now I want to, let's see, I figure I should go say a few words about object-oriented programming, classes and instances, the difference between them, attributes and methods for C programmers who haven't met OO programming. Is that worthwhile? Okay. So a C++ class is equivalent to a struct. And we don't have we've got a writing stick over here. So I'm assuming you all have written C, and you would be familiar with the construct type def struct car color, we'll say string. I'm going to use a bit of a mixture of C++ and C here. String color, and we might give it other. So this is an attribute. It's a variable member of the class. So the thing about classes and structs and types, when I say type, I mean this type and class are equivalent, is they're a concept. They aren't something that you can count. It doesn't make sense to say, I have car, or it doesn't make sense to say to car. Car is a type. It's a concept that represents something with 4 wheels and a steering wheel, an engine, and some other things. I can say, here is a car, and here's Paul's car and Doug's car. They're both car, right? So they're identifiable. So there's a key concept here in object-oriented programming of a type and an instance of a type. You will have seen, okay, what does this statement do? What int I?
Creates an instance of an individual.
Excellent. Creates an instance of an int. And if we say equals 0, it's initializing the instance, right? Same thing with double D equals. So it's the same thing with these types. I can say car, my car. Creates an instance of car. And I can say car, Doug's car. Creates a different instance. So the instance is countable. It's named, it's identifiable by its name. So that's really an instance has a relationship, is a relationship to the class. Paul's car is a car. Doug's car is a car. And then each class can have properties. It can have methods, like gas pedal, that takes maybe a percent of value.
Method different from a function?
A method is just a fancy name for a function that belongs to a class. And the key difference is that a method operates on the instance of the class that it's a member of. So think of it like Paul's car, my car dot gas pedal 50 will set my car going at a power value of half gas pedal halfway down. It won't affect Doug's car, right? So that's another key element of this instances of an object having methods, and the methods operate on that instance. So the method is defined in the class. All cars have a gas pedal, right? All instances of a car have a gas pedal. But when Paul pushes his gas pedal down halfway, his car moves and Doug's doesn't.
We hope.
Yeah, or something's very wrong.
Unless he's behind Doug's car.
Okay, there are a couple of ways of initializing. Just like you can say int A equals B if you've previously defined and assigned to B. You can say car, my car, that declares an instance of my car equals Doug's car. So that would copy all the values from Doug's car over into my car. Doesn't make so much sense in the physical world, but that's what it does in objects.
That's called envy.
What?
That's called envy.
Envy, yeah. Here's another way that you'll often see of initializing instances is to pass in their initialization parameters when you instantiate them. And you can have multiple parameters that you pass in. So you'll see both of those techniques of declaring and initializing classes, instances of classes. Okay, so we talked about, we can change Paul's car color if he wants to get it repainted and make it fuchsia, then we can say Paul's car dot color. So this is the same syntax as you use with structs, right? And so you just assign to a member of to an attribute of the class. Classes can contain classes. So if I had done, again, let's use C syntax. If I'd done type def and just to make the comparison with a struct, which I hope you all are familiar with, struct seat. Now, I'm using capitalization for type names and lowercase for variable names of that type. And this is a real common convention in C++. So seat might have a string called material, leather, cloth, whatever. So car has 4 seats, right? And so we could have an array of strings.
Array of seats.
Seat colors.
Sorry?
Array of seats.
Array of seats, sorry. Sorry. seat. Yes, thank you. Okay, so now our car has got 4 seats.
Wouldn't the 4 belong over there on the right of seats? Because you're defining
Thank you,
4 there.
yes, thank you. And then the way that we assign to that is we say, my car dot seats dot material, okay? So the reason you need to do that, to know this kind of stuff, is because you'll run into ROS expressions like this one, pub.publish. So that calls the method publish on the class, on whatever class pub is. Pub would be a ROS publisher, naturally enough. And you pass it some parameters. Okay. Any questions on object-oriented programming in C++? That was like real brief, but hopefully it's the concepts that you needed.
Do you make use of inheritance at all with?
No, you almost never see inheritance.
Oh, God.
Um, okay, so I'm going to do a little quick demo here and show some of. So that's the end of C++. So that wasn't too painful, was it? You know,
Piece of cake, gosh.
if you know C, you can pretty much do C++.
Add that to my resume.
Just remember, C++ is to C as lung cancer is to lung. That's all you need to know.
Oh, that's cruel.
I remember that one.
Okay, can you all see
Just
this
give me credit
okay?
when you use it.
So the first thing we're going to start up is the ROS master, which you do with a command called ROS core. ROS core is already running. All right, well.
So the ROS core command was in your path, and that command just started the
Yeah, and
master.
yes,
Now it's a process that continues to run.
yes, that's right. That's exactly right. Where did my big window go?
I don't do that much command line stuff, so it always freaks me out to see command line stuff, because when I did command line stuff, it was 9,600 baud. So
And it was gone.
I had a big screen here.
Oh, Flexor writer.
CT1024, Southwest Tech Terminal, that was my first computer terminal. 32 by 16.
desktops?
I don't. No, it's not. I don't know where it went. And there it is. This double screen thing is doing a bit of a number on me. Okay, so a couple of things that you should notice.
I'd smoke a cigarette, come back in, get another cup of coffee. Okay, so it still might not be done.
When ROS core starts, it gives you the name of a log file that it's sending all its logs to. So everything that spits out on the monitor is written to this log file. You also get a log per process. So it's very helpful to look at that when debugging, and it'll warn you if your log usage gets over 1 gigabyte, and then all you have to do is delete your old logs. The only thing I don't like about this is it gives the log a humongous name like this. It's a URI. Okay, so our ROS core is working now.
And it's running on this laptop you're typing on?
Yes.
And you're running Ubuntu, right?
And I'm running Ubuntu. That's right. I was going to run ROS run, turtle sim node, and turtle sim key. So the way you run commands on ROS is you do ROS run, one of the ways, ROS run, and then a package name, and it's got command completion, turtle bot sim. So we're going to run simulator, turtle sim, turtle sim node.
So it's file completing commands that ROS run understands?
Yeah. And we have a little simulator plot showing a little turtle up here. So now we will start another instance. Apparently I have to set all of these screens to presentation mode. ROS run, sim, teleop, key. And so this says you can use arrow keys to move the keyboard, to move the turtle.
So is turtle sim one node, or did you just start two nodes?
I've just started the second node, and when you're beginning, actually, you really want to use a lot of tabs when you're using ROS, because you get one process to run. When you're manually starting the processes, you can start one in each terminal and print out and see what each process is saying. Towards the end, I'll show a way of using a script that will start multiple processes at once. So we can hopefully, why is the turtle not removing?
Don't you need to move focus to that window?
No. Hold on, I think I know why.
What's this cat key?
I've got to have an include. No. I'm expecting more to print out. What's going on?
Murphy just came in the room.
I think he did. That's cool. Why is the turtle sitting up running? Oh,
There it is.
if I used the right keys, it would help. Okay, so let's now take a quick look at what happens at, we'll run a ROS tool called ROS topic, and we'll do help first. Two of the useful commands on subcommands of ROS topic are to echo, which prints messages off of a topic to the screen, and list, to list the active topics. So
What was the problem you had to?
I needed to use the arrow keys. The regular TurtleBot uses the VI keys, J, K, I, and so wrong keys. Using arrow.
So you have two nodes running now, the turtle sim and then the turtle key.
Exactly.
So the key communicates to the sim and then the sim does.
Exactly. And also the ROS master. And so when I
So
started
those are
up the...
Those are going through the ROS, the turtle keys publishes and then the
Well,
ROS master distributes to the sim.
No, they just use, the ROS master is just a name server. And so when I started the turtle sim, it said unsubscribing to command bell messages. And when I when I started the turtle key, it said I want to subscribe to, I want to publish turtle messages, and the master told it, go over here and talk to this guy. He wants to listen to them.
So the messages go straight.
Yeah, messages go
They don't
straight
go through the
those.
server, the server
Right,
just
right.
gave them the name.
Exactly,
Gave them the hookup.
because otherwise the master would be a hotspot, right? A bottleneck. Okay, so ROS topic list lists the topics that exist at the moment that are known, and we've got turtle 1 command bell. That's the one that causes the turtle to move, and then there's a color sensor and a pose. A useful, an interesting and helpful command is RQT graph, which displays the graph of the connected nodes. So Teleop Turtle is publishing on Turtle 1 command bell, which is sending messages to Turtle Sim. So these are the so apparently something in there kicked off a third node. But so I told you I lied when I said there were 2 nodes running. Something in there kicked off probably Turtle Sim kicked off a third node.
So what was pose?
So pose tells where the robot is. Now, a useful command is to do a ROS message show pose. Pose, what's pose under? Let me see, I forget what.
It's twist. I believe it's twist, isn't it?
Echo, let me not get distracted by that. And let me instead start another tab. Oops. So ROS topic echo will print the messages that are published on a topic. So we'll echo / turtle1 / cmd val. And we'll go back and start our, here's my, my arrow keys. Okay, so we'll make the turtle move. And here are the messages that were sent. And I really wish one of these was in a different window. So we'll do a ROS topic echo. And you'll see as I move the turtle, see here, it had an angle, I hit the right arrow, it got an angular velocity of -2. And then if I hit the straight ahead arrow, it gets an X velocity of 2. Okay, so this is how, this is a tool that lets you examine the messages that ROS nodes are passing between each other. So it's pretty useful. Any questions on that?
What's the relationship between the node and the class? Classes.
Nodes, a node is a process, and a class is a type. So they're different things.
But
And what about a class instance?
A class instance is an instance of a class. So
Is it a process?
it may or may, typically it would be typically you'd run it as a process in ROS. So typically you'd have a class for publishing your Maxbotics sensor, a class for running the robot, maybe a class for doing control.
Can a node have more than one class? One
Yeah,
class
yeah, it
logic
could.
in
It could, for sure. Yeah, a complicated node could. The ones that we're looking at, because this is a gentle introduction to ROS, don't.
So each node is a license for the class?
Yes, yes. In these examples.
Does this turtle come as an example that comes with ROS?
Yes. Okay, so we've listed the topics and we've echoed them. You can also manually generate data to feed to and manually publish it, which is useful for debugging purposes. So if I paste this in. Terminate my keyboard app and so ROS topic pub is a subcommand of ROS topic that actually publishes data, and it says these arguments mean to publish on the topic /turtle1/command val, publish the messages geometry geometry messages /twist, and the values 2.0, 00, 00.5. And we'll see the turtle do a sort of an arcing move. Okay, so we manually apply data to cause the robot to move. So this is one of the, last week I made the point a number of times, and David questioned me on it. What is composable? What does it mean to say that the software is composable? You can see elements of that here, where we've got a piece of the software that is simulating a robot. We've composed it with another piece that was a keyboard teleop, and just now we used a utility to publish a message on a topic and cause the robot to move. So it's a little like Unix, where you can string together things with pipes, you know, cat something to grep, pipe to grep, pipe to less, and whatever. Okay?
Well, is there kind of a minimum performance level for whatever you're running ROS on? Like, or is it kind of it depends on how complex your robot is?
It depends. That's really the real answer. And it depends on how much data is having to be handled. Like cameras, vision uses a lot of processing power. Displaying graphics, like Jason was showing last time, use a lot of processing power. This stuff uses almost no processing power.
Okay. So that if you go with, say, the Pi 2, you're probably going to run into limitations much quicker than if you had, say, a netbook versus i7.
And so what it'll limit you is in how many frames per second you can chip video through the thing.
Right. Okay.
Paul, what's the little processor you have on the lawnmower?
So I use this netbook on
It's
the
a netbook?
Yeah. So it's and ROS likes to have, Linux likes to have. I usually configure Linux with like 20 gigabytes of hard drive, and if I'm running it in a virtual machine. So it doesn't need that much. ROS is only a couple of gigabytes, and in terms of processing power, a gigahertz processor is fine for these simple kinds of things. When you start running the GUIs like Jason was showing last time, you want to have a decent laptop like this, and that's where it's advantageous to run the navigation software on the netbook, because it doesn't use that much power, that much processing power, and then run the GUIs on your laptop.
So is your netbook like atom-based?
Yeah,
On a
yeah,
1.2
exactly.
gig or something?
Exactly.
Something like
Yep. Okay, so now we're going to go through a real program. I promised software, and you guys asked for it, so here we go. An introductory remark. You will see here examples of all the things, C++ syntax things that we just went through. So, we had to do that preparatory stuff to, so that you can understand the code that we look at here. But a second point is, you'll find this very templated. You'll see the same code over and over and over again, just written exactly the same way, because there's just one way to do the things that have to be done. When a node starts up, okay, so let's walk through what has to be done when a node starts up. It has to initialize, and it's given a name. In this case, the name is publish velocity. And so when if we ran RQT graph, that graphical program that showed the nodes, we would see publish velocity as a node on it. We declare a node handle. A node handle is the thing that's used for, is the class that's used for interacting with ROS in terms of publishing and subscribing to messages, and setting parameters, a bunch of other ROS core services. So this line means declare an instance of a ROS : node handle called NH. It doesn't need initialization because most of its methods are static. Okay? Now, remember I said you need, can you guys see this okay with it highlighted like that? Remember I said you need to know these angle brackets and the : well, this is why. This is a line that says I want to advertise something on a topic. So let's take it a piece at a time. We're declaring a publisher, an instance of the class publisher in the ROS namespace. The class is named pub, and we're assigning it to the output of nh, our node handle, .advertise method, telling the compiler that advertise will be dealing with geometry messages : twist. So that twist is the message type that tells the robot to move. That's the one we were just looking at when we echoed the topic. And the topic name to publish on is command vel with a Q depth of 1. Sorry. Does anyone have any questions about that?
Q depth?
What?
What is a Q depth?
So you can, ROS lets you specify the depth of a queue of messages. So when you're spitting out messages, if you care about losing them, you might put a large queue size on it. If you don't care about losing them, like typically robot movement messages, you wouldn't care if you lost some. So if the subscriber went away, in fact, you really don't want a deep queue size because you don't want to start up your robot subscriber and then it takes off because it's playing back the last 1,000 messages that were in the queue, right? So this lets you modulate that. Okay, so we've declared an advertiser, created an instance of the publisher class called pub that will advertise on the command vel topic, and will publish geometry messages : twist on the command vel topic. What it's doing here is it's advertising. So it's telling the master, I've got these messages on this topic. And so when a subscriber comes along, the master knows where to point it. Okay, the next line declares an instance of the class rate, and we give the instance name rate, pass an initialization parameter of 2, which makes it run at 2 Hertz. So the ROS rate is kind of a nice class because it lets you run things at known periodic rates, and it accounts for the fact that maybe the class will take a while to run, but so it subtracts the amount of class runtime from the deadline before it should run again, so that if the class took 100 milliseconds to run and you asked it to run every 500 milliseconds, then it would only wait 400 milliseconds before causing the class to run again.
How did it know it took 100? Did it report that on initialization, or does it measure that each time it runs?
Neither. The way these things normally work is they say, okay, the user wants me to run at this rate, so let me think about this. It can set deadlines up ahead. So if it was, it can run the first time. Once it runs the first time, it can look at where it started and when the next deadline is, and just do a sleep for that amount of time. Okay, here's the second half of the Publisher program. So notice these things are short. We got like 7 lines of setup, of declaring the publisher, and then 5 lines of actual publisher program. So the while ROS is okay. While ROS is okay. So this will loop as long as ROS okay is true. ROS okay will become false when you Control-C it, or it receives some other indication that it should terminate. So this is just a way of ensuring a clean shutdown.
So ROS OK comes from the ROS master?
Somewhere like that. I don't know exactly where it comes from. I know Control-C is one of the things that will cause OK to become false, but I don't know if that's all of them.
Can I ask you, what, are you writing a node here, or are you writing, maybe is there anything besides nodes? Is there a program that calls all these nodes, or is there just a bunch of nodes?
So we're writing a node here. There's no class here. Notice that we're using classes, but we're not instantiating.
You're creating a node right now.
Yeah, we're writing the code that will create a node, and where it actually becomes a node is in this ROS init method call, function call, actually. So it becomes a ROS node at that point, in the sense that it can communicate with the ROS master, and it will appear on the graph, on the RQT graph program. So it's considered a node.
Well, is there no such thing as a, I guess what I would call a main program that calls all of the nodes, or do you just have a bunch of nodes? How do you group them together?
Great question. So this one, so again, just a little bit of a longer answer. This goes back to the composability piece. You write little bitty nodes in ROS that do small jobs like publish a sensor or drive a motor, and you compose them together on topics, and you run the whole thing from a batch file, effectively a batch, something like a DOS batch file. It's called a launch file in ROS, and I'll go through that a little bit later. And it's something that starts up all of these nodes together.
I teach C++, and in the courses I teach, we say a class is a template that you use to manufacture these things that are called objects. Objects are just a container that surround what C programmers traditionally think of as variables, with a little bit of extra glue that lets you hook in a way to call specific methods or procedures. So you will build a program in C++ out of normal C-looking like code, but instead of simple variables, you'll be playing around with these objects. when he's talking about a node, it is a program that runs in isolation under the control of the operating system, and it's using network communications to talk to other programs that are also simultaneously running somewhere in the network that makes up this robot. So maybe the best way to view a node like he's talking about now, it's just a self-standing program with some weird-looking variables inside it that come from all of these blueprints that we've created to manufacture them.
That's a great explanation. Thank you.
Sorry, I do this all the
Thank
time.
I still want
I think
to,
he
I
gets
guess, what's the top level code for a robot? I've got this robot. What's the top level? It sounds to me like it's a batch file.
Yeah.
It's the launch.
Let me show you an example of that. Just
Before you go down that route, the answer to that is there actually isn't any top-level
Yeah, that's not a good
of
answer.
everything. It's all of these independent things talking to each other over the network.
Right, based
Yeah.
on how
The
they're scheduled.
master,
Yeah.
the master
You
sits
can't
up
have a
at the
bunch
top.
of things out here that don't know each other. You've got to have something that pulls them together. It's saying this is for my robot.
So this is a launch file, and it starts multiple of these nodes, and so it's written in XML, and each node element that begins with this less than node declares a package. This one's starting with turtle sim. The following node begins with DPRG agitator, a gentle introduction to ROS. Okay, the type is a poorly named name, in my opinion, for the executable, the name of the binary that should be run. So you notice that on that code we were walking through, it had a main. So, and all of our nodes have a main. So they're all separate programs.
You know, like your car doesn't have a main program if you think of all the component pieces of a car, right? I mean, the steering wheel does this or talks to the...
Simultaneously with the
different things
engine
happen,
running.
right? But
This
there's no
whole,
like...
this whole discussion is kind of where we're stuck in teaching people how to program right now. We're talking about parallel programming in
Yeah.
this ROS environment. And all of us were trained in single process, sequential, do this,
Yeah.
do this, do this, do this mode. And we don't naturally think in parallel. And yet, you fire up a laptop, you turn on your email program, listen to music, watch a YouTube video simultaneously. All of those programs are running in your laptop, and you're just wandering around picking one topic at a time to deal with at any moment. So we have a whole slew of these nodes out in different processing elements, doing their thing, all talking to each other over the network. And this launch file thing here basically says, boot up my robot and start all these little programs running, and then they'll start talking to each other and make life happen.
What a
And
great
really,
explanation. Thank you.
And you can rearrange a lot of this stuff in this launcher, right?
Yeah,
I mean,
yeah.
really, that's
Yeah.
the beauty of it is, rather than we
That's
think in
really
terms
cool.
of initializing this, and this in the classical program sense, but here it's just throw all this stuff in the bucket, make sure you got enough of it to handle everything, and it'll run.
Exactly.
And that's just the initial config. You can also live substitute stuff
Yeah.
as you
Yeah.
go.
Yeah.
And change it around.
Yeah.
And yes, it won't work if there's a critical piece missing that is core functionality to your robot. If there's a subscriber that disappears that runs your motors, then it's not going to work. But you can
Exactly.
just fire it up again and or try variation of it and plug it into the live system, and it'll keep on going.
Yeah.
It may or may not work.
Exactly. Great. You guys get this.
So you're saying your launch is your, what I call the top level?
In a sense, it's your top level thing that pulls all the pieces together. And the pieces are these individual little programs that all run in parallel.
Well, I can check that.
Yeah.
But
On
there has to
different
be something,
computers.
this is the thing that defines for this robot. And then you're saying it's what you call it, a launch?
Yeah, the launch file.
Launch file?
Yeah, and the launch file names the nodes, states which nodes will be
Is
run.
launch file part of Linux or
No, this is ROS. Node is a ROS concept.
the launch file is
is
The ROS
a ROS concept, yeah.
Does ROS core look for this launch file?
No, you run the launch file with a command called ROS launch. And in fact, I'll do that right now. I think. So we'll run.
Do you have to list the master in the launch file, or is that always launched?
That's a great question. The launch file, the launcher is smart. It will start ROS master if it needs to, but if there's already a ROS master running, then it won't start one. And so
That was, what was it that you said runs that on?
you run. So I'm about to run a launch file. You type ROS launch as the command.
You were saying that there's something separate from the log, the ROS master, that you were telling me to run this?
No, just the ROS launch command, and then the ROS launch command looks to see if there is a master running.
Okay.
And if there is, then it doesn't need to start one. If there isn't, then it will start one. I have a ROS master running right now. I ran ROS core in another window earlier, so it won't restart. It won't restart the master. So we run ROS launch EPIG agitator, and then just range follower is the only program. And let me just actually to run this, let me just make sure. That. Okay, so range follower is a little Robotics program. So let me just plug this thing in.
What is the sensor called?
This is a Robotics sonar. It has the reason there are two USBs going to it. One's used for one pulls +5 volts in, and the other has a sort of a phono jack that's used for serial. And so if right now, since I plugged it in, /dev/tty USB 0, so I plugged it in, it created the device file /dev/tty USB 0, which this launch file that we were just looking at can then use. So the ROS launch. Okay, so let me say a little bit about, and this is your program that you wanted, and I'm sorry I didn't have any motor controls that take serial ports, so I hope you'll accept a simulation. And what I'm going to go through here is the code for ROS nodes that does the subscribing and publishing of the data from the Robotics sonar. So there's a Robotics sonar node that publishes the distance readings, the range readings from the sensor. There's another node that subscribes to those sensor readings and looks at the distance, and if the distance is more than a meter, or between 0.4 meters and 0.5 meters, then it sends the robot stop command, sends a command bell, or publishes on the command bell topic a twist message with 0 velocity. If it detects a distance less than 0.4 meters, it runs the robot backwards. If it greater than 0.5 meters, it runs the robot forward. So it's your follower robot, right? So if we point it at the table here, and we get closer, it'll go backwards. A little further away, and it'll stop. Further away still, and it'll go forwards. So let's see. Okay, so this is the code that I want to enable you guys to write. And there's not more than a couple of dozen lines that are different between the programs involved here. There are only really two nodes. There's the Maxbotic range publisher, and there's the robot motion controller. I call it a range follower that subscribes to the range and publishes robot motion commands. Okay? So hopefully that's enough of an explanation of what's going on here. Okay. We were walking through this. Okay, so here's the... David.
Sorry, Paul. A mundane question. Each of these nodes begins with main, so you have to have a separate file for each node, right?
Exactly.
You can't have a bunch of mains.
Correct.
When you compile them, you do end up with a bunch of mains, though.
They're all independent.
They're independent binaries.
Executables.
They aren't all linked together. They're independent
not all
binaries.
linked. All right. Thank you.
Individual
All right,
processes.
that's what I needed.
Yeah. Okay, so so we walked through the initialization where the program made itself a ROS node by calling init, and it advertised the topic that it's going to publish on. Now this is the second half of the program. While ROS is okay, it's going to assign, it's declaring a twist, a geometry messages : twist class called vel message. It's assigning to the linear and angular members of the vel message. So it's saying vel message.linear.x is 2.0 meters per second, vel message.angular.z is 0.5 meters per second. Then it says pub.publish. So remember, pub was the publisher that we instantiated in our setup. That calls the publish method on that, passing in vel message, and that sends a message out to anyone that's subscribed. If no one's subscribed, who cares? This guy doesn't care.
It'll do that every 2 seconds.
At 2 hertz, yeah, every half a second.
2 hertz.
Right, and then, so the rate.sleep, rate was that class that we instantiated with an initializer of 2 hertz. So rate.sleep will sleep for as much time as it needs to in order to run this loop, in order to exit the sleep after 500 milliseconds. And then we just jump back into the while loop, go around the while loop. So just forever.
And while it's sleeping, the processor can be doing other things.
Yeah, exactly. So we can run this with the ROS run. ROS run is, so there's 2 programs that you use for running ROS programs. ROS launch, we saw before, runs a launch file, which is that script that starts multiple nodes. Or ROS run will start one node at a time. The syntax or the command, both of them have the command format of the package name and then the executable or the batch file name. So the point here is that I can have my own binary names that might be the same as somebody else's binary names, but as long as they're in my package, then it's not going to collide.
Where's your package defined?
The packages, if you'd hold that thought till I go through how to build it, I'll explain that. Okay, ROS run dprg agitator, public, my pub. Okay, my pub is the name of the publisher. So I built the code that we just walked through. The code that we just walked through doesn't have the pound includes at the top. So, it wouldn't compile as is, but I'll put the source code out on the web and it'll all be buildable. In fact, we'll build it today. Okay, so it's now running, and we can show that it's running. With ROS topic list. And we see there's still a bunch of turtle-related commands out there. ROS topic, let's see, RQT graph. Let's see what's running. Oh, range follow is still running. Oh, I guess I left that thing running. Okay. Where is it? Okay, and now we'll refresh.
And also not shown there's the poll process is running and we're all subscribing, I think.
All right, I'm a bit confused here.
That's the hope in the class anyway.
Just,
Unfortunately, sometimes my students sleep.
oh. I think I terminated the master. So let me start the master again. Now let me run. Okay. QT graph. Okay, all I did was start a ROS core here, and so there's nothing significant running. There's this node that's running the RQT graph, and that's this RQT GUI Pi node. Now we'll run ROS run dprg agitator my pub. Okay, now if we refresh this graph, we see that there's a node called publish velocity, and so that's the node that exists. No one's listening to it, to what it's publishing right the moment, so it's not showing the topics. Let's see. So, okay, but we can see what's being published with ROS topic. What? Oh, listen. We want to look at what's being published, ROS topic list, and we see command vel is being published. You always have ROS out and ROS out ag. They're just always there. They're like standard out on a process. And then ROS topic echo / command vel. And this is what it's publishing. We just looked at the code that says it publishes X as 2.0 and Angular Z as 0.5. Yeah? Now, we can go one step further and start up a simulator. ROS run turtle sim turtle sim node. And okay, and the reason why the turtle isn't running is because the turtle actually listens on /turtle1 / command vel, and I'm publishing on command vel. So let me fix that right quick. And in the process, you'll see how to compile a ROS node. So we'll just run and here's our, okay, here you see the include files, only 3 include files needed to make this thing build. And we'll zip the topic to /turtle1 / command vel. To build it, you just run catkin make, and you can see it's rebuilding my pub.
What is catkin? Is that just some variant of make? Or?
Yeah, it's an homage to Willow Garage that invented or developed ROS. A catkin is a willow seed clump. So someone thought it'd be cute, I guess. Okay, so we'll run ROS run again, and we're still not.
You gotta rerun your DPRG adjutor thing. You just rebuilt it, don't you have to rerun it? You run the
Yes,
turtle sim, but
thank you.
not running the adjutor.
Thank you, thank you.
Yeah, kill that one and start a new one. There you go. So now your turtle's spinning.
There we go. So now we have some forward motion and a little bit of curvature. Okay. So we've now walked through the code to do a publisher.
Cool.
Any questions on it? It's pretty straightforward stuff, right? It's every publisher looks like this. You know, once you've seen one, you've seen them all.
Okay, now, Paul, just because I'm trying to get clear. So right now, what you have is you have your sonar sensor, which communicates, it has a serial port. It's communicating to a USB to serial chip, which is putting it to your laptop, and then you're starting it in your laptop.
That was a demo that I did before. It's not this demo.
Okay, now what's in this demo then?
So what's in this demo is just
a loop.
The template, the publisher that we just walked through the code for, that publishes a command bell message. It goes forward and a little bit of angular rotation.
Okay, so in this one, you're not tied to any sensor.
I'm not
You just
using-
created a node, basically.
Are you doing that
Okay.
twice a second?
Yes.
In your actual robot that you move along with, how often do you update those values? I assume 2 hertz isn't fast enough for a real robot.
No. I don't remember the exact number, and it differs by sensor. You know, different sensors, you'd want to run different sensors at different speeds. But I honestly don't remember if I run it at 10 hertz or 20 hertz or, sorry.
That number, that rate number is then hertz, that's free?
Yes, it's in hertz. Okay, and so we'll terminate that, and the robot stops. This robot has a very nice feature that it stops if it stops receiving messages, so that if your publisher stops sending velocity messages, it won't just travel on forever and bang into stuff.
That's the turtle sim.
This is the turtle sim, and the turtle bot has the same characteristic. My robot needs to have that. It doesn't right now because I wasn't that smart when I wrote it. Okay. All right, so now I want to switch gears a little bit and go through how to build the ROS node. We just did the back end of it, but this talk is about getting started with ROS. So we'll assume that let me just terminate stuff here. We'll assume you're starting from scratch. Okay, so you've just installed ROS and you followed the instructions in Agiter and on the web for how to install ROS, you don't have any place to put source or build nodes yet. So these instructions start you off on that process. So the first thing you do is you make a workspace. So this is a one-time thing where you just have to have some place that you're going to build ROS programs in. And then the second step is you make a package for your project. So I'm just going to cd to dot and move catkin ws to catkin ws dot small. And okay, so I actually have a catkin ws dot save, which is where I do most of my work, but I shoved it aside The name Catkin WS is not significant. You can use any name, but you know all the examples use that, so that's what we use. That's what I use. Okay, so we'll do a make dir minus p. Tilde. Tilde is a Unixism for your home directory. /catkin.ws/source. Okay, that made a directory called catkin ws/source. cd. Okay, bang dollar is a Unixism for repeat the last argument. So that did a cd to catkin ws/source. Now we do a catkin init workspace. And that has created a file called cmake.lists. We don't care about it. We don't need to worry about it. cd ... And now we can run make. It's an empty workspace, but it should still make. And so this is some kind of a sanity check that your build system is working. And it goes away for a little while and it will finish. Because it had nothing to build there, but at least you know the ROS install is working correctly. Okay, so now we can make a package for our project. And so we'll cd to source. We'll do catkin create package. Now the arguments here are the names of the packages that this package will depend on. So I happen to know that it depends on these because I just do. Okay, so now if we do an ls, we made a package called dpig ROS.
You have to create a different package for each robot, or can you have more than one robot?
You've got any amount of flexibility in that respect that you want, because each package can contain any number of binaries. Maybe a better answer is what should you do, as opposed to what could you do. Typically, you'd make a package that encompasses all the functionality for one thing, like for one sensor, for one motor, for one mapping algorithm, and then so you tend to make packages that are fairly fine-grained. But you can put any number of programs in a package that you want.
The package would hold several instances, classes.
Yeah, absolutely, and several nodes. So dpig ROS, I'm going to repeat this command and make the package dpig agitator. Just because.
Kind of like when you go to the grocery store. If you're gonna have a barbecue, you don't want your mustard and your mayonnaise and your hot dogs and your buns to all come in the same package. But yet the barbecue depends on all of those packages.
That's a good analogy. Okay, and we can run catkin make again if we want. And it'll make it.
Unless you like barbecue and blender.
Okay, so that's how we create a workspace and a package. Now, to build a ROS node, we add source code, and we have to edit cmake list.txt to tell ROS what to build, and then we build a new node, we source the environment, and then we run the node and test it. So here are the commands to do that. Part of catkin make built a file called, in CAD/WS, called devel/setup.bash. You should put that in your .bash RC. So .bash RC, .bash RC is a file that Unix runs when you start up a new shell. And it's typically where you put your environment variables. And so here I've got environment variables that set some Turtlebot variables and make an alias. And why don't I see one that sources? Oh, there it is. Source. So first of all, I start off by sourcing opt/ros indigo setup.bash, and then I source ~/catkinws/devel/setup.bash. Actually, it turns out I didn't really realize this, but this command runs the preceding one, so it's not hurtful to run it twice, but I don't actually need both of those instances in there. And what this does is it sets up all those ROS environment variables. So it sets up ROS root, ROS package path, ROS master URI, and so forth. All the environment variables that ROS needs to work.
Paul, is it indigo? Is that a particular flavor of ROS you're running?
It's the release name. So the release names begin with words that start with E, F, G, H, and we're up to I. The next one is J. For Jade is the name of the next release. Okay, and then you saw us run ROS core, ROS run, and there we go. And then the subscriber okay. So any questions on building? I think it maybe won't go just have you watch me type all those commands to make, and I mean I've made them, but the next thing you have to do. Okay, there's one thing I do need to show you, and that is in the source directory is where we have our dprg editor package. Each package is a directory, so packages and directories are synonymous. This cmake lists file is the equivalent of a make file. It uses cmake, which is like the modern version of make, and it's where you tell it what the package dependencies are, and the things that you have to edit are that, and also the program names. So you said this is how you declare a new binary that should be built. With the add executable, then the programs I'm building are mypub, mysub, and maxbotics, and here are the corresponding source files. Oh, and I'm also building range follower. And then here are the target link libraries, and they're all just, for each executable, they just default to the Catkin libraries. So that file is something you have to edit, just like you'd edit any make file when you add a new program. Okay? Okay, so the subscriber program fits on one slide. It's like 4 lines of code. Actually 7, because there's a method up here. So let me start with the method up here. Okay, so we've walked through a publisher, right? So now I want to walk through the code for a subscriber. The first thing we do is, so the way subscribers work in ROS is that they declare a callback. When they say I want to be a subscriber, they declare a callback function that gets called when a message comes in from the topic that they're subscribing to. And so that's what this function definition is here. Velocity message received is what that's an abbreviation for. And it'll be passed geometry messages, : twist, which it'll call vel message. So there's a message that will be given to it when a message is received on that topic. And all it does at the moment is ROS info prints a log message, received a twist message with vel %d. This is a printf, printf kind of syntax. And then here's where you do something with the message that you received, like run a motor or something. The main does the usual ROS init. We've seen that many times. It declares a node handle. We've seen that. It declares a subscriber, which is almost exactly the same format as declaring a publisher. So declares a ROS subscriber called sub, and it assigns it the output of the nh.subscribe method. It's going to subscribe to the topic command vel, and when a message comes in on command vel, it's saying please call vel message received. And then ROS spin just goes into a idle loop and waits for Control-C or anything else. So that's all there is to a subscriber code. Could hardly be simpler. And we can run it.
So the format of the message is specific to the node that's publishing it? There's no predefined templates?
No, there are predefined, and that the message name, geometry messages : twist, defines the format of the message, and you can show that. As an excellent question. You can show the format of the message with ROS message geometry messages / twist. ROS message show. Okay, here's the format of the message. It's has a member called linear, and within linear it has 3 float 64s for X, Y, and Z. Those are how fast it should move in the X, Y, and Z direction. So obviously this format would support quadcopters and other things that can go sideways and up and down. And then angular, how fast it should rotate around the X, Y, and Z directions. And so a key value that ROS brings is the standardization of these message types and the topic names. You can still invent your own topic names and your own message types, but if you use standard names and types, then you can interface with other components that other groups have built. Like TurnSim, you can take a LiDAR code and just not even have to modify the LiDAR module, because it'll publish on a standard topic name with a standard message type. Same with a camera, you can just suck in video and do your special thing with it. So this is a way that ROS enables reusability. It enables you to use code that was developed in Spain, in Malaysia, by other labs all over the world, because everyone more or less standardizes on these topic names and message types. And when they don't, then you slap them, or you rebuild code and submit a bug and ask them to provide them with some fixes and say, please merge this, and
So that's binary compatible, big endian, small endian, all of that?
yes, yes. The ROS transport, actually, it uses boost serialization to serialize these messages, which ensures endianness, cross-endianness. Well, we're getting pretty near done with all this stuff, because okay, if you want to clean up, you just CD to CAC and WS and remove the build and devel. Don't remove source. Don't blow away your source. That would be bad. Here's your sonar publisher, Kareem. So we've done the demo, we've looked at the messages, right? So why don't I just walk through this code? It's nearly the same as the publisher that we already looked at. It's got a few more lines to deal with the fact that we're dealing with real hardware here. So ROS init, we already saw. Declare the node handle, declare the publisher. This time we're publishing a range, sensor messages, : range.
So that's a standard.
It's a standard message type, and we can show the message type with ROS message show sensor messages / range, and it's got a couple of enum definitions here for whether it's an ultrasound or an infrared ranger. There's a header containing sub-elements of a sequence number, a timestamp, and a frame ID. The frame ID is a concept, I'm not going to go into that here, but it's a concept that says, where is the sensor on the robot? And how do you relate it back to the origin point of the robot? So here's the variable, the radiation type, ultrasonic or infrared. Field of view, I don't know, how wide does it look? A min and max range in case anyone's interested. And then here's the range variable. So yeah, those are the members.
And is range expected to be normalized to something like meters, or?
ROS standardizes on the MKS units, so meters, kilograms, seconds. There's a document that defines what the standard units are, but those are three of them that you run into.
So if you have a nonlinear sensor, you're expected to do the conversion inside the publisher before putting it out on a wire?
Yeah, because otherwise you'd be violating the meaning of this message, which is that range is in meters. And in fact, you'll see that I do that. It's not for nonlinearity, but in the next page, in the code, the Robotics sensor emits readings in millimeters. So I just divide by 1,000, and then it's in meters. Okay. Publisher, we've seen this code before. Okay, I declare the range messages : range. I declare a receive buffer that I'm going to read the Robotics sensor data into. I declare a float called a range, which is the value of the range. I declare the file descriptor. I open /dev/tty USB 0. And if the file descriptor is less than 0, then I print an error, like I forgot to plug the USB in. Okay, this is the rest of the publisher. While ROS is okay, we've seen that line before. Do it forever. Now the Robotics output format is the capital R and then 4 digits of range actually in tenths of a millimeter. No, range in millimeters, I'm sorry. Range in millimeters. Followed by a carriage return. I found that by starting up Minicom, the TTY terminal, and saw what it was printing. I was like, okay, this is obvious. I declare a variable I that I'm going to use as an index into an array, and as I read one character at a time, off of the serial port. So while read returns non-zero, I read the file descriptor into the receive buffer indexed by I. If I just read a carriage return, then I replace the carriage return with a zero, with a \0, which makes it a null terminated string. So that way, C functions that deal with strings will be happy, and break out of the while loop. So I'll read characters until I see carriage return, then I'll break out of the while loop. Now I have all the characters lined up in this RX buff. I say range equals string to float, str to f, string to float. Pass it in the address of receive buffer 1, element 1. So I'm skipping over the leading R, because the RX buff got that leading R, and that's not a number, obviously. Is divided by 1,000 to convert millimeters into meters. Assign, so that's range. Assign, I plug range into the range message, .range. I'm putting a timestamp on it. Look, here's a useful function, ROS : time : now. Now is a method, static method in the time class that returns the current time. So assign that to the header, timestamp, print a message out to ROS info. Here's another way of doing rep messages. Before we saw the printf style of printing a message. This is a C stream style. And then pub.publish. We're done. Do that forever. That's your loop. That's all there is to it. And the robot controller, to make it do the range following, is even simpler. There's only one page, I think, one page of code. No, 2 pages. Okay. So remember something that subscribes has a method, a callback, that gets called every time a message comes in. So this is the callback. The function is called, I called it sonar message received, and it receives a sensor messages : range, which I call range message. So I do a print that I got this message. Then I declare a geometry messages twist, which I call val message. Because remember, so this node is going to receive range messages that are published on the sonar 0 topic, and it's going to publish command val messages to make the robot run. So this is the one that makes my little robot go backwards and forwards. The program that makes the robot go backwards and forwards. I just declared a float called R and pulled a range out of this message just so I've got something short to type. Here's the test. If R is greater than 1, it's further than 1 meter away, or greater than 0.4 and less than 0.5, then val message.linearx is 0, so stop. Else if it's greater than 0.5, set linearx to 0.5, else it must be less than 0.5 and greater than 0.4, so less than 0.4 it must be. So set a backwards velocity. Then pub.publish publishes it off to the robot. The second page is just does the initialization for that. So ROS and init and node handle we've seen. Subscriber we've seen. Here we're saying subscribe to the topic sonar 0, and you'll get and this is the function that you should. This is a callback function. Here we're saying publish geometry messages : twist on /turtle1 /command val, which is the topic that the Turtle1 simulator, that the Turtlebot simulator listens for, and then spin, go to sleep. And that's all there is to it. So does that make sense to you guys? Any questions?
It's easy. Just you gotta remember all the commands.
Well,
like so many things, so
yeah.
right, you gotta work through the exam.
There's a learning curve, and like I said last week, it's a fairly steep learning curve. hopefully this has helped you come up on it some. But, expect to spend a while finding your way through it and getting used to it. And the fundamental question, again, comes back to that question from last week, is ROS right for me? And it's something that only you can answer. Are you decent at C? Are you comfortable working in a big software system? Are you open to learning Linux? And Python is really good to know. You don't have to know Python. Do you want to build more capable robots that you can develop from scratch, David, with vision and things like that you just would never be able to build? Are you open to using modules that other people have developed and learning how to make them work for you? These are the questions. There's no one answer that's right for everybody.
I have a question, just to return to your previous slide. The only timing that was specified in your demo was the timing of the publisher, which was to run at 2 hertz. Everybody else was just told to spin, so are they actually blocking? Is that what's happening? They're waiting for they're suspended while they're waiting for a blocking input?
This is really a system design question. There's no one answer for every system. In the example code, I did in the publisher, I did a rate.sleep, which caused the publisher to have a 2 hertz publish rate. The subscriber just waited till whenever it got a message. So it would run at 2 hertz because
Right.
there'd be a message coming every 2 seconds.
But when the messages are not coming in, is what I'm asking. What's it doing at that time?
It's
Is it
sleeping.
like-
It's waiting for a message.
So it's like as if it was called a blocking read?
Yeah, it is a blocking read, that's correct. But to expand upon that a little bit, in the Robotics Sonar app, I don't have anything that sets the rate. It actually runs at the rate that the sensor emits messages, because it's a block. I do a blocking read on the sensor file descriptor and get 1 character at a time, and then when I've see the carriage return, then I build up the message and publish it. Then the subscriber is sitting, waiting, listening for that, and so then it'll run once I've published it, and then the simulator is sitting waiting for it. So it'll run again.
I noticed that the topic names look like file names, /turtle1 /something something. Are those actual files somewhere on the drive?
No, they're not. They just chose the slash in order to enable hierarchical naming of topics. And there are ways that you can...
Like the places, the dot that's used in the classes?
Yes, exactly.
So I think you just answered this, but let me ask it again to clarify. Is it publishing at the speed that the Robotics sensor, or is it publishing every 2 hertz because that's what it's assigned?
It's published... So the first demo I did where there was just a publisher and a subscriber was publishing at 2 hertz because I set a rate.sleep. The second demo, the Robotics demo I did, is publishing at the sensor rate. Whatever that is.
But the subscriber is only looking at it every 2 times a second.
No, the subscriber gets every message.
He's blocking. He's just waiting for the
he's
next
just...
message.
That makes sense for a sonar sensor too, because it varies so much. So here, like in the range follower robot controller, we say subscribe and run the sonar message received function whenever you get a message. So here's the sonar message received function. That will run every time it gets a message.
So, and when we did echo, that would basically be real time.
Yeah.
So we were seeing them fly up on the screen as
Yep.
fast as that's possible.
Exactly right.
I see a lot of references to using Raspberry Pis as the control machine on a robot, but then having Arduinos running sensors and motors and things, and they use ROS serial to tie those two together. Is ROS serial easier on the controller side than simply communicating to the Arduino over the USB connection to it?
That's a great question.
and it's actually a fairly deep question. I actually wrote an extension to ROS Serial that runs over the network. And it's receiving a surprising amount of use. ROS Serial is a way of taking messages that are published and subscribed and exporting them to a non-ROS system. And so an Arduino is one such non-ROS system. Where I've been really surprised that ROS Serial over TCP is getting used is to run ROS on things like Macs, Macintoshes, and export data to Macintoshes or other non-Ubuntu systems. The question you have to ask about whether to use ROS Serial is, do you want ROS to run, do you want to be able to publish and subscribe on that non-ROS computer? ROS Serial lets you do that. But it's not the only way of getting the data out there, because clearly I could send messages out to an Arduino saying M for motor +2, and have a little bit of firmware on the Arduino that gets this and runs the motor at whatever speed I send it to it, right? So you don't have to run ROS Serial to use. In fact, when I was thinking about putting this demo together, and if I would have had more time and motivation perhaps to put an Arduino together and get it to run a motor, I wouldn't have bothered with ROS Serial, because I think it's much easier to just send a serial stream, carriage return delimited, over a serial port and have the Arduino read and then take that as a number that it should PWM the motors with.
So you have an agent on your control computer that's simply talking
Yeah.
to Arduino.
Yeah.
So the application I've got, I have a robot that has about 7 stations on it, each one with a TC.
Each one with a what?
breadboard. It's got a TC
Oh, yeah.
and a breadboard.
Yep,
Those things are Arduino
Yep.
software compatible.
Yep.
But students run code in each one of the
Right.
TCs
Right.
to manipulate
Right.
the sensor.
Right.
And then I tie it all together with a Raspberry Pi.
Right.
And I'm not really willing to let that robot move around much because everything about it is a different student project. So you can imagine how well behaved that will be. I have radio control override everything.
Yeah. Yeah, so there's 2 different approaches that you could use, and depends which one's going to be right for you. If your Arduino has a whole bunch of sensors and motors, then you might find it more convenient actually to run ROS Serial and subscribe on the Arduino and publish on the Arduino. That way you don't have to write your own protocol to distinguish between those different sensors and different actuators. But if it's only doing one device, then hey, it's just a whole lot simpler to just stick something out on the serial port.
Just a comment, when I retired from the Air Force, I was running a supercomputer center with a Frame 2 supercomputer, and we were in the throes of building massively parallel high-performance computers. And the whole architecture limitation was cross-communication between all the elements.
Yep.
Cray really made their money over mashing data between nodes at extremely high speeds, networking.
They had a non-blocking crossbar switch.
Yeah. I just saw an article this morning when I was getting ready to come over here, and the United States is committing to build a 180 petaflop supercomputer, and Cray Research is helping arbitrate the movement of data around.
Yeah.
And Intel's in the middle of this building communications channels. They're using light beams to transmit information from one node to another. It's getting crazy out there.
So, I don't want to keep you all I've been going at it for a while here. I've got 2 short demos, if you all are interested. One, I think you'll like them both, actually. One is how to plot stuff. One of the things one of the difficult things about building robots at the hobbyist level is you typically have poor debug facilities. Like everything you have to write printf for the output of your PID loop, the output of your encoders, and then you got screeds of data flying past you, and you got to try and debug it, right? So if you all are open to a couple more minutes, I've got a couple of short things to show you along those lines. So I'm going to ROS launch now DPRG agita program, and here and here's the sonar. Okay, so now an interesting thing to look at might be the range. So let's run RQT plot. Oh, look at that, I remembered. Okay, and we'll zoom out with the right button, right mouse click, I think, zooms out. Come on.
Is that using PyLabs?
I don't know what it's using. Okay.
Can you then check auto scroll? I don't know anything about this plot. So you feel like you're
The one, it's not scrolling.
Auto scroll off.
Yeah.
No, I'm trying to zoom. I got to press this one. That's what it is. Come on.
There you go. I think there's just bandwidth.
Yeah, I'm zooming out.
Oh, there you go. All right.
Okay, so let's turn auto scroll back on. Okay, so now in red, I'm plotting total 1 / command val / linear / x. So this is the speed that the robot is being asked to run at. And then total 1 / pose / x is how far it's traveled. And we can zoom back in. We go backwards, and now our speed has gone negative. Okay, so that's that's a really useful. I mean, that's pretty nice. You can imagine that being useful in debugging, particularly things like PID loops. Okay. The other demo is I'll move my regular workspace back into Captain WS. And I've got a whole bunch of stuff in here. Nito robot, a Razor IMU 9DOF. I did a bunch of code work on that. ROS by example, volumes 1 and 2. Excellent book, excellent examples. RL500 is my mower. SwiftNav Pixie is a 2 centimeter RTK GPS unit that I'm doing a driver for. The diag demo. Okay, so what this is a simulation of a battery, a camera, and a GPS. And there's a node that's publishing a sinusoidally varying value. It cycles about every 10 seconds or so. And that's detected by the camera node, the battery node, and the GPS node to cause them to do different things. So what I'm demonstrating here is the robot monitor that prints out the status. And we can expand it, and we can double click on that and see that the battery charge is going down to 72, 52, 41, and its status, now it's down at 3 and it's red. It's gone to red status for failed. Now it's back up to 24 and it's gone to yellow status, and now it's back above 50 and it's gone to green status. So that's a real nice kind of status display showing you your charge, and it's just real easy to put together and get nice GUI. Now here's something even sexier. Check this out. You're really going to like this. ROS run QT configure. Dynamic reconfiguration of variables. Pops up a GUI. It lists the node that is advertised that it has stuff that you can dynamically reconfigure. So imagine dynamically adjusting your PID, your K and I and KI, KP, and KD variables on the fly. So your battery worn level is defaulted to 30. I can crank it up to 80, and whenever my battery charge here drops down below 80, it will go into, it drops straight into warning level. So this is the battery worn level dynamic reconfiguration variable. Okay, so that's just kind of a teaser for cool, neat debugging tools built into
Did you have to
ROS.
put anything special in the code to enable that, or you
Yes.
can basically
Yeah.
find any variable?
No, you can't define any variable. I did put special code in, to register for callbacks. So when I make an adjustment, it calls a callback, and the callback plugs in a new variable for the warn level. But there's maybe half a dozen lines of code in it, so pretty powerful. So
It's interesting, I see a lot of these topics that I put in my own code, and not so elaborate, but even some of the methodologies of having subscribers and publishers, kind of do that within a program, but this is more elaborate, better thought out, and of course, more flexible.
yeah, I mean, this is designed to run really big, complicated research robots, and there's a lot of power in it. It is a relatively steep learning curve, but well.
Like using a sledgehammer, gotta be careful you don't drop it on your foot.
Yeah, that's right, and you should use it for appropriate things, not for swatting a fly, but for breaking apart a concrete path, and if that's what you got to do. Any other questions?
Well, we saw that you had several projects going on in your workspace. Have you made any progress on your Nito robot?
No, I'm not actually working on a Nito robot. The Nito LiDAR is done.
Okay.
That's published.
Yeah.
The mower is my only active robot project.
But I know you have a Nito on your robot.
The Nito LiDAR?
Yes, you did.
Yeah.
And
It works, it's done. I
Yeah.
mean, there's nothing more to work on with it.
So we haven't seen it, Paul. You haven't brought it in for a show and tell or anything.
Oh, sorry.
Yeah. No grass on the floor.
So
what does it do? I mean, what are you doing with the LiDAR data?
Okay, that's a great question. So you remember last week Jason did a demo where he told the robot to go from here to there, and it used a Kinect effectively as a LiDAR to develop range measurements for what the robot was looking at, and it compared the range readings to a map and localized itself based on the range measurements. Well, that's what I'm going to do with the real LiDAR is because ROS is designed to do that. There's modules already built that you just bolt together with these publish and subscribe topics and use it to localize the robot.
But just since you have it on your outdoor robot, what sort of range are you getting off of it?
Not very good, not enough to actually be workable in daylight.
Yeah.
It can see about 2.5 meters, which isn't enough to look around the lawn.
Yeah.
So I'm actually waiting for some new LiDAR units that I expect to come on the market in the first half of this year that will have ranges more like 40 feet or 40 meters. I forget, but size,
so
big
like
enough to be significant for a lawn application.
Spinning LiDARs.
Spinning LiDARs.
Okay, because I'm going to say LiDAR light is obviously out already.
Yeah, but it doesn't.
It's kind of slow.
It doesn't run fast enough to operate as a spinning LiDAR.
Right.
Yeah. So that's the intent for that. And then the 2 centimeter GPS is the other form of absolute localization. Anything else?
Tell us about your mower. What sensors do you have on it? How does it position itself?
I have to say at the moment it doesn't. So
The intent is to mow on.
Is it actually using vision or is it pre-programmed to go along a specific path?
I can only speak to my intent, so it doesn't do any of these fancy things. But last month, Jason showed. I intend for it to go along a paint style path. Run up this way, then down. Rather than the Roomba sort of like go every which way and hope that after a while you've covered all the lawn. So to make that happen in a mower requires great accuracy. You really need a couple of centimeters of kind of level of accuracy. Otherwise you're going to leave strips unmown, or you're going to like cross over and remow significant strips. So certainly the GPS is a key element of that. And then LiDAR localization is the other key element. But I don't have it working yet, and nor does anyone else in the world, so. But that's why I'm working on this kind of stuff. Anyone else? All right, thank you very much, everyone.
You get a standing ovation.
Standing because everyone wants to run.
Hang out for the drawing. Okay.
Nice.